Hello again, 7th graders, and welcome back to my YouTube channel. Be sure to subscribe and smash that like button at the conclusion of this video. You may recall that when we last met, we were talking about Bezouts' lemma, and we were searching for pairs of numbers h and k that fit the formula. Well, I didn't really have a good answer, though, for a way other than guess and check, right? But here, how about this? What if we consider that it may be useful to note that what we really need are multiples of a and b that are going to differ by d. A and b, that's these numbers here, that are going to differ by d. So that is to say, one of yesterday's examples, we had 14 and 26, greatest common factor is 2. We may find it easier to find h and k if we simply list multiples of 14 and 26 and stop as soon as we have a pair that differ by 2. So consider, since 26 and 14, GCF of 2, well, here, when I start listing these, as you can see, I don't have to go too far before I hit 28 right here. So right there, I see that 28 and 26, yeah, these in fact differ by 2. See? So I would extend the list, of course, and find more pairs of numbers that fit. So, that is to say, I could just, keep on going here. Sorry, tap something there. As we can see, I come up with, 156 as well, right? So that's going to be our, 6th number there on the sequence. So I'll say the 6th number. And meantime, our 11th number down here, here's our 11th. This is the 6th, by the way. So, 11 times 14, if you add 2 to it, that would equal 6 times 26. See? I'll zoom out a little bit so you can see the whole list. Again, obviously, we had these before. But, I can make, make an answer here by simply looking for pairs of numbers that differ by 2. Okay? So, we could do this here. Consider if I did 7 greatest common factor 20, we know that that's going to be 1. So, again, there's 2 ways to look at this, of course. Whenever you have this, you could always say 1 plus 20 times h equals 7 times k. Or you could also write 1 plus 7 times h equals 20 times k. Okay? So, again, this one's actually relatively easy over here because it's pretty clear that h, if h is 1, I'll have 21 here, so got 1 and 3. And of course, using that method I showed you yesterday, we know the next one up is going to differ by the opposites, or I shouldn't say opposites, but we're going to swap the factors as add-ins. So next pair is going to be 8 and 23, for instance, you see. If I go h and k on this side, like so, again, we can use this same kind of method that I was showing before, and that is start showing these multiples of 7 and 20 till they differ by 1. I'm just going to cut right to the chase. That difference is going to be 119 and 120. Those are going to be the 2 numbers, which is to say 20 times 6 to get to the 120, and 7 times 17 to get to the 119. See? And then next numbers in the list will be 37 and 13, because I will add 7 on the k side, add 20 on the h side. That's all. So, before you do exercise 94, continuing on here, be mindful that the set of multiples of a given number is infinite. Okay? So, set of multiples will also include the 0. So when I say multiples of 8, I need 0, 8, 16, ... You have to enter your answers like this, with the set braces and with that points of ellipsis to indicate it'll keep going. So if you're asked to write 7 and 10, the least common multiple of 7 and 10, and that multiple set. First of all, you need to understand the lowest common multiple of 7 and 10, of course, is 70. So I write m sub 70. And that multiple list will start with a 0. Please remember to start with a 0. Okay, you should go to do this. That's 210, like so. Okay, makes sense? So that's what you're going to do. I'd like for you to complete through exercise 99 on page 46, and I will talk to you again tomorrow. Be sure to smash that like button, subscribe to my channel, and be good for your parents. Have a great day.